We're continuing to write linear equations in slope-intercept form. Now, sometimes we know the slope of a line or the rate of change for some quantity as well as just one point on the line. So let's say we're given the following information. We're given the slope equals 5, and we're given 1 point on this line at -2 and 1. Okay, to write an equation in slope-intercept form, we know we need the slope of the line and the y-intercept. Well, what we can do is we can use the slope-intercept equation to find the y-intercept. So let's start with plugging in what we know into our equation. So we know that the equation looks something like this. Y equals mx plus b. Okay, this is the slope-intercept form of a linear equation. Well, here we have the slope, which is going to be m, and we need to find b, which is the y value of the y-intercept. Well, here we're actually given a point, an arbitrary point on the line, which is actually the coordinates x and y. So we can plug in this information and solve for our b value. So let's go ahead and do that. So we know, okay, so this is our x value and this is our y value. So let's go ahead and plug these in. We have y, which equals 1. So 1 equals m, which is 5, times x, which is a -2, plus b. b is what we want to solve for. It's the y value of the y-intercept. So let's go ahead and solve for that. So we have 1 equals -10 plus b. We can add 10 to both sides, which gives us a b equals 11. So we have our b, our y component of our y-intercept. So now we can write the equation in slope-intercept form. So we go back with y equals 5x plus 11. And that's how we get our slope-intercept form when we're given a slope and 1 point. Notice these two values, y and x, are just the coordinates of an arbitrary point somewhere on the line. So we can actually plug any two values in here that correspond with a coordinate point on that line. So this is just the general case, and this is actually a very specific point somewhere on this line. Okay, so don't want to confuse you with that. This is the y-coordinate of an arbitrary point on the line. This is the x-coordinate of an arbitrary point on the line. And this is the y value of the coordinate or the point y-intercept. Okay, just want to make sure we're understood there. All right, so let's do a few more of these. Let's get a little more practice in the notes. Let's say we're given the slope. We're given the slope 4/3. 4/3, and we know that 1 point on the line is 2 minus 2. Okay, well, we need to find our y-intercept, and we can do so by plugging in our slope and our x and y value into our slope-intercept form equation. So let's do that. So we have a -2 equals our slope, which is 4/3, times x, which is 2, plus b. b is what we want to solve for, so let's go ahead and do that. -2 equals 4/3 times 2, if we just multiply the numerators, is 8/3 plus b. We can solve for b by subtracting 8/3 from both sides, so we have b equals -8/3 minus 2. We can go ahead and convert 2 into a fraction with a denominator of 3, so we can go straight to subtracting these. So we have 2, so we have -6/3. 6/3 is same as 2. And we can go ahead and subtract these. Instead of subtracting, we can add a negative. So this is going to be a -14/3. That's our b value. So let's go ahead and write our general equation. We have y equals m, which is our slope of 4/3, times x, and we have a -14/3. Okay, it's not always pretty, especially when we're dealing with fractions, but this is the general equation of the line that has a slope of 4/3 and passes through the point 2 and -2. Okay, let's look at another one. Let's say we're given the slope, of -0.8, and we're told that the line passes through the point 1, 0. Let's go ahead and use what we know to find our y-intercept so we can complete the general form of the slope-intercept equation. So let's plug in, we have 0 for y equals m, which is minus 0.8, times x, which is 1, plus b. Okay, we can go ahead and rewrite this. Minus 0.8 plus b. We can solve for b by adding minus 0.8, or just adding 0.8 to both sides. So b equals 0.8. And we can write the general form of our equation. Y equals our slope, which is minus 0.8, x plus 0.8. And that's our answer. That was actually pretty simple. You can see how having very simple points makes the equation and our job very simple. Okay, 1, 0 is a very good point to use. It just reinforces the importance of picking points when we can, when we're actually graphing a line. And we saw that in an earlier section. So let's look at another one. We have a slope of minus 6 and the point 0 and 1/4. Okay, we could actually bypass solving for the y-intercept by stopping and thinking about what the y-intercept is. It's actually the y value when x equals 0. So we actually know the point on the line where x equals 0 because we're given it right here. Okay, so this is actually our b term, 1/4. It's the y value of the y-intercept, or where the x value is 0. So we can actually, since we know this piece of information, we can go straight to writing our equation. We have our slope of minus 6x, and it would just be plus 1/4. Okay, we're actually given our y-intercept here because our x value is 0. Anytime we can identify this, it'll save us a little bit of work. Let's look at another one. Let's say we're given the slope. We're given a slope of 3, and line passes through the point 5, 7. Okay, here our x value isn't definitely not 0, so we're going to have to solve for our y-intercept. So let's go ahead and plug these pieces of information into our equation. We have 7 for y equals 3 times our x value, which is 5, and plus b. And b is what we want to solve for, so let's go ahead and do so. We have 7 equals 15 plus b. We can subtract 15 from both sides, which gives us a b equals minus 8. And now we have all the pieces of information that we need to write the general form. So we have y equals 3x minus 8. And that's our answer. Okay, let's do a couple more of these. Just trying to get a good hang on it. So let's say we have the slope. We're given the slope of the line is minus 1, and it passes through the origin. So 0, 0. Okay. Here we can see that our line passes through the origin, but we still need to find, well, we know the y-intercept. Again, up here, we saw that our x value is 0, so our b value is just the y-coordinate. So here we don't even have to solve for our y-intercept again. We can go straight to writing the equation. We have y equals minus 1, so minus x, and then that's our answer. Our y-intercept, our b value is 0. Okay, anytime we can notice things like that, it saves us a lot of work. Not a lot of work, but it definitely saves us some time. Okay, let's get some room here so we can do a few more. Okay, let's take a look at, let's say we have a slope, we have a slope of 5/3, and the line passes through the point 1 and 1/2. Okay, we need to find our y-intercept, the b value, the y value of our y-intercept. So let's go ahead and plug in what we know. So we have 1/2 equals our slope times x, which is 1, plus b. B is what we want to solve for. So we have 1/2 equals 5/3 plus b. we can solve for b by subtracting 5/3 from both sides. So we have b equals 1/2 minus 5/3. Let's go ahead and use the cross multiplication strategy so we can actually solve for this. So we have 1 times 3 is 3 minus 2 times 5 is 10 divided by 2 times 3 is 6. And this gives us a minus 7 over 6, which is our b value. So let's go ahead and write our equation. We have the general form y equals our slope times x minus 7 over 6. Okay, and that's our answer. So we're solving, we're given the slope of a line, and we're given 1 point that the line passes through. And we can actually use what we know about our slope-intercept form to write a general equation. Okay, we can take the point, the x and y coordinate, plug it into our general equation along with our slope, and solve for b. Once we have our b, we can go back and write the general form of the equation of the line. Okay, so we're actually kind of working backwards in a sense from what we've seen, but it's just another way that we can manipulate the slope-intercept equation to get the form that we need and get the information that we need. So no matter what pieces of information we're given, we should have all the tools to actually write our linear equation in slope-intercept form. We'll see some more examples over this in the next section.